All right, so earlier we ran into this integral and we had to wait. And now that we have our tangent substitution tool, we're ready to go back and handle this problem here now. So we're starting with the arc length of y equals 3x squared on the interval from 1 to 4. So now we're ready to actually compute that. So let's do that. So we recognize that we are dealing with a tangent substitution. All right, because this is 1 plus 36x squared. Okay, now the formula calls for a squared plus x squared. So the first thing I need to do is rewrite that as some quantity squared. So then I can do this process. 1 to 4, square root 1 plus and 36x squared is 6x quantity squared dx. Now we could take a moment and switch over from x to u, but there's no need to that. Recognize a here is 1 and stuff inside there is 6x. So I just make the substitution 6x equals a tangent theta as described in this problem here. All right, number with it is 1. So 6x equals tangent theta. So when we differentiate 6dx equals the derivative of tangent theta, which should be secant squared theta d theta. So dx is going to need a 1/6 secant squared theta d theta. Okay, everything's set up fine. I don't have to worry about anything there. Okay, and so now we're ready to start, working through the problem. So we go in and replace the 6x with tangent. We replace the dx with that stuff, and we work the problem out. So now I'm not going to bother changing my limits of integration, all right, from x to theta. So I'm just going to kind of leave them off, or if you want, just write theta equals question mark. But usually I just leave them off. I don't know what it's going to be. This is going to be square root of 1 plus tangent squared. 1 plus tangent squared is secant squared. And then on the outside here I have 1/6 the derivative of tangent, which is secant squared theta d theta. And so we keep working this out. That's going to be 1/6. And again, I'm going to stop worrying about limits of integration for a little bit. I'm going to have square root of secant squared, which will be secant. And then that's going to be times secant squared. So I'm actually going to have the integral of secant cubed theta d theta. And this is where your reduction formula once again becomes very, very nice. Becomes very, very nice. So just to go back, the reduction formula for secant, it says it's secant of n is secant of 2 powers lower, tangent, all over n minus 1, plus n minus 1 over n minus 2 over n minus 1, secant of 2 powers lower. Okay, so in our case here, so we just got to keep those formulas in the back of our mind as we're doing these, and keep them handy. So secant would be secant of 2 powers lower, which would just be secant of the first power. So 1/6 here. So that'll be secant joined with the tangent. And that's over n minus 1. So 3 minus 1 would be over 2. And that's plus n minus 2, which is 3 minus 2, which is 1 over n minus 1, which is 2. 1/2 integral of secant 2 powers lower. And for secant theta, you either want to remember the way to do it, or just remember what it is. I think it's honestly, for me, easier to remember what it is. So working this out, 1/6 and 1/2 is going to be 1/12. Going with secant theta, tangent theta, plus 1/6 times 1/2 will be 1/12. And remember, the integral of secant is the ln absolute value of secant theta plus tangent theta. Of course, all this would normally be plus a constant of integration, but we're doing a definite integral. So I left off my limits of integration for a while because I didn't want to keep writing them. So now it's time for me to convert back over to theta. And what I know is this: tangent theta is equal to 6x. So I draw the picture. Tangent's inverse goes in either the first or the fourth quadrant. First or the fourth quadrant. So it doesn't matter here with secant which one we draw. The secant's positive in both of those quadrants. So tangent of theta, remember tangent is opposite over adjacent. So opposite, 6x, over the adjacent, which is 1. And we use Pythagorean theorem to find the hypotenuse. It would be the square root of the sum of the squares. So square root of 1 plus 36x squared. Okay, and now with the picture, we're ready to compute our secants and tangents. And then we're ready to evaluate it. Okay, so let's do that. 1/12. Secant would be that stuff over 1 over the adjacent. So square root. And tangent is just going to be 6x. So it's going to be 1/12 times 6x times the square root of 1 plus 36x squared plus 1/12 ln absolute value of secant plus tangent. So square root of 1 plus 36x squared plus 6x. Right, and then all that is evaluated between 1 and 4. Right, so we can find the arc length of this function. Find the arc length of this function. And that really then becomes a big old calculator problem. So I've gone through here on my calculator and computed this 1/12, and then 6 times 4 times the square root of 1 plus 36 times 4 squared, plus the ln of the square root of 1 plus 36 times 4 squared, plus 4 times 6, 24. And then minus 6 times 1 times the square root of 1 plus 36 times 1 squared, or square root of 37, minus the ln of that square root of 37 plus 6. And when I do that, I get my answer here of 45.12. 45.12. So that is the arc length of my original function. It's 45.12 units. Okay, which should be the arc length of that original function, which I believe was 3x squared. Right, between 1 and 4. I found the arc length to be 45.12 units.